Uh, yes, so we're live. Good morning, everyone, and welcome once again to our ongoing international webinar, Paleo Worlds History, Heritage, and Horizons. So, day before yesterday, it was an extraordinary day of learning for us. We began with Professor Jerry H. Lips, who took us back to Darwin's revolutionary insights on natural selection and paleontology, reminding us how fossils not only shaped evolutionary thought but also transformed the history of science itself. Then Professor Ashok Sahani transported us to the age of giants with his fascinating account of the Indian dinosaurs, dead but doing well, showing us how India's fossil record continues to enrich global paleontological narratives. And finally, Dr. Rajiv Nigam turned our gaze from the gigantic to the microscopic, revealing the applied power of microfossils and foraminifera in reconstructing oceans, climates, and even human history. Together, these three sessions highlighted the true spirit of this webinar, connecting history, heritage, and horizons in paleontological research. And today, we are back to widen our lens to look at paleontology through the ages, an Indian perspective. For this, we are deeply honored to welcome Professor Vijay Sathe, one of India's foremost vertebrate paleontologists and archaeozoologists. So, welcome, sir, on behalf of the history enthusiasts and BLDA's Srimati Bangaramma Sajjan Women's College. We warmly welcome you, sir. I also welcome our honorary president, Sri Nandan Shastri ji, founder vice president of the History Enthusiasts, Ms. Nidhi Katti, the principal and the staff of the Bangaramma Sajjan Women's College, and all the members of the audience who are watching us, who have been supporting this webinar and taking benefit of it. So, now I would like to introduce our resource person. Professor Sathe is former professor in the Department of Ancient Indian History, Culture and Archaeology, Deccan College Postgraduate and Research Institute, Pune, and currently serves as affiliate researcher at Deccan College and visiting professor at Nalanda University. Over 4 decades, he has made pioneering contributions to quaternary vertebrate paleontology, taphonomy, paleoenvironmental studies, the origins of domestication, prehistoric rock art, and the interpretation of animals in myths and ancient art. His fieldwork has spanned the Narmada, Ghodh, Godavari, and Kurnool valleys, as well as the Manjra River basin, where his discoveries have given some of its most significant Pleistocene fossil evidence. His research also extends to archaeozoology, studying animal remains from the Harappan and Chalcolithic sites across the subcontinent, and to paleohistology, helping us understand ancient diets, evolutionary relationships, and vertebrate pathology. Professor Sathe has mentored numerous postgraduate and doctoral students, authored a monograph and more than 80 research papers, and represent Indian paleontology at conferences across the globe. His contributions have been recognized with the Dr. A.P. Khatri Award for significant work in Indian archaeology, the Nehru Trust Travel Award, and several other honors. So it is a privilege to have Professor Sathe with us today, a scholar whose career has so seamlessly bridged paleontology, archaeology, and cultural history. So please join me once again in extending a warm welcome to Professor Vijay Sathe as he speaks on paleontology through the ages, Indian perspective. So the stage is yours.
Yes, first of all, I'm very much thankful to the organizers of this webinar. And this gives me an opportunity of reaching out to the hitherto unexplored audience in other parts besides the state of Karnataka. As my talk is focusing upon the development of paleontology, if I'm allowed to say historiography of Indian paleontology, but I would be definitely specifically mentioning about vertebrate paleontology. So, and that too in a period which is tertiary and beyond. It doesn't get deep in time. And so I discuss about this, the development of subject of paleontology in the context of how in colonial and even much in ancient times, how the fossils were considered to be and how the actual idea about paleontology emerged over the period of, I would say, thousands of years of methodical research. I would say at the same time, a lot of resistance against such researches in the past. And now what we have is an entirely different field, which is emerging as a wonderful gap between prehistoric and modern fauna, and a lot of important clues are getting available to us with this study of prehistoric fauna. So I request for the next slide, please. Next slide, please. Yes. No, no, no. Yeah. Uh, s- Today, this paleontology has attained such a state where, in fact, in 21st century paleontology, which we call it, we'll put in a context of modern times renaissance of paleontology, where we have this slogan that find more data, more technology, and more integration, implying that interdisciplinary interactions are very, very important. Paleontology is cutting across all the subjects, all the disciplines of branches of sciences, and letting us know more about the prehistoric fauna. And next, please. So current issues that, in fact, all of us know about: ecology, migration, extinction. How can we date back these fossils into a slice of time? And fad, that is first appearance datum, and lad, that is last appearance datum. When did they appear first, and when did they die last? All such dates. At the same time, what subsistence, what the food they had, the diet they had, and what could have been the cause of death for those organisms whose relics we find in the form of fossils. At the same time, the interactive episodes with early man, evidence of human activity, because when I'm pushing the subject of paleontology much into quaternary, then I find that yes, a prehistoric man is also interacting with prehistoric animals, which fall into the period of Pleistocene, and there the early man was certainly not just sharing the landscape with animals, but also making use of them for source as a source of food. So, how exactly these interactions have been in the past? At the same time, how influential these human beings must have been towards the extinction of animals? Was it just the overkill, or was it just climatic change, or other physiological issues which led to extinction of these animals? And besides the fact that, lastly, we have this very important issue of dealing man-animal relationship in terms of a prehistoric man encountering animals and leaving behind their impressions on rocks, which is known as rock art. Animals and rock art. And animals and rock art are always taken as an honest documentation by prehistoric man about the environment, biological environment that he has encountered, come across. So this can also be taken as a fossil record, but this is a painted fossil record. This is a record which has a human agency involved in portraying the animals. So if even if the animals have some sort of a human intervention in terms of artistic innovations, yet the fundamental animal form, which we call a zoo physiognomy, or the zoo the physical shape of an animal, gives us clues about what kind of animals, what fauna could have been surviving or living or sharing the landscape with prehistoric man. Next, please. And in that process, with the extensive research of these many years, now it has become possible to identify the last datum or the appearance datum for these many animals. So I'm just confining at this time for just for an example that we have several species of elephants which became extinct. We have so many species on the right hand side, and left hand side is all about prehistoric, and the right hand is which have outlived, which have survived at the present day fauna. Of that, next please, we have uh, uh, we have this number of species such as hippopotamus or cattle or ostriches or stegodons or Paleoxeron nomadica or Paleox, another primitive species of elephants, and zebrine horses, which are known as Equus nomadicus. They all have become extinct from Indian subcontinent over the period of time. And the dates on the right hand side will highlight that exactly what time they disappear, and we are no longer finding them in fossil record, but cattle or the extinct bovine is domesticated, and today what zebu we have is deriving from Bos pneumaticus, or the extinct cattle of Pleistocene. So this is what I'm talking about, that we have attained these I wouldn't call it kind of an achievement, I would call it important contributions of fossil record. And then a modern renaissance, which is helping us in finding out precise clues to this animal's appearance or disappearance. Next, please. But when I take you to this a much deeper history of paleontology, I find it very interesting that it can stretch back to 1st century BC or up till almost 10 to 14th century AD or 14th century Common Era, that you have Xenophanes, Herodotus, historian Herodotus, geographer Strabo, then another natural historian Aristotle, then Apollonius, Pliny the Elder, Philostratus, Muhammad Ferishta from ancient Persia, Ibn Sina, Ibn Sina from ancient Persia, and Ibn Battuta. All of them have one or the other way referred to fossils, referred to animals, and also talked about anatomy. So Aristotle's the animal parts of animal or philosophy of biology with animal partibus, volume 1 and 2. It is probably one of the most astounding examples of how exactly the study of the anatomy of animals and man was closely watched, observed, and documented by Aristotle. But as we go further in time, proceed further in time, it is 1825 when this term paleontology, that I don't need to talk about these basics of the subject here, but I'm just giving an example that who coined what subject when, and it was only in 1834 that Waldheim for the first time introduced the subject of paleontology into geology. Next, please. But when I again take you back to this, next, please. Aristotle's very interesting details about how he is studying animals, teeth, lower animals' teeth, human teeth, and he's describing how the incisors, canines, front teeth, he says, but now we know there are incisors, canines, the teeth in the back side of the jaw, how they all have different applications and how they help us in mastication and digestion. And then at the same time, he example of human teeth, and then in fact canines, he referred to them as dog teeth. The entire thing is very interesting example of the way back in 1st century you have this study of anatomy being described, and which is giving us an example of how the subject built up brick by brick over the period of time. Next, please. So it has been obviously a caprice of nature, sort of waste of time, sort of a not at all an interesting subject of research that was happening in medieval times. But 12th to 14th century, because interestingly, the churches forbade and they found this waste of time, as I said before, caprice of nature is written over there. But then we do have some exceptions, such as Bishop Ratisbon, and then we also have Arezzo, who had come up with the fossil record, but they just put it within the limits of great floods. Deluge, they cause it, they just call it as cause of death and burial. Then again, when we come to 14th century and 16th century, when with Leonardo da Vinci, who comes up with extensive flood, the hydrodynamics and whatnot. In fact, he has also talked about anatomy and human and plant taxonomy, and also he goes to the extent of discussing about the depositional history of fossil record. And then we have Agricola and Gesner. Next, please. These two gentlemen have made phenomenal contribution to zoology and mineralogy. So the right-hand side, this gentleman called Agricola was the one who termed coined the term fossil, and the left-hand side, Conrad Gessner, he wrote a book, Fossil Objects and Chiefly Gems and Stones. And through this literature, where Gessner considered Aristotle just like his guru, and imbibed all the information that was coming from those ancient literature and developed his own methods of identification. So if you see his literature today, after 400, 500 years, you find that you may find it with laced with some sense of humor, that kind of diagrams have been drawn, kind of information written, but that's the most fundamental important information that we have come across. Next, please. So basically what we see here is the natural historians, post-runners are really were helping us out and developing this theory of biology, the philosophical angle to it, and how historians were also coming up with their detailed anecdotes. But next, please. Quick run through these pictures and their contributions, because without their mention, I think the paleontology would be incomplete. Georges Cuvier, the gentleman who is considered father of world paleontology, and he worked in a natural history museum, Paris, and it is he who had discussed and described the fossils from 1795, his publications, and he clearly mentioned that they are not basically part of flood. They have been ancient, and they are not. They don't conform with this ongoing notion about flood and all. But he is the man who talked for the first time about anatomy, and his adage is very, very important. It's a very interesting one, where he says that show me your teeth and I'll tell you who you are. So that kind of a description tells us about his in-depth knowledge, and he is leaving behind a plethora of literature, which has come very useful to all of us here. Then we have another gentleman, William Buckland, who was a very close friend of Mary Anning, and he has studied geology and fossils much in detail, but important contribution of his is coining a term, coprolite, for the fossil dung, which Mary Anning had discovered, and she shared these ball-like objects to Buckland. And when they were broken, a lot of fish fossils, fish bones came out of it, and it was found out that they are nothing but the prehistoric dung. And so the Greek term, coprolite, was also coined by this Buckland. And on top of this person, there is a Sir Richard Owen, who is considered to be one of the most important characters of colonial, the Victorian England. And in fact, if you see the term dinosaur, it has been coined by him in 1844. He was the man behind the development of Natural History Museum London, and entire collection that he has studied. He comes up with some of the finest discoveries, and his interpretations are always, of course, well known. His taxonomical research is also well known. I'll quickly go to the next one. And then, of course, we have this tongue twister, seashells at the seashore. This is Mary Anning, whose contribution, of course, has inspired generations of paleontologists across the globe, I would say. Next, please. Immediately next, please. Yes, now we draw your kind attention to this interesting era, interesting period, especially colonial East India Company, and then Indological studies happening with growth of global science, colonial science. William Jones come to India, and then establishing Asiatic Society of Bengal, and British Empire establishing, and at the same time, many natural historians at the same time, the botanists, zoologists, surgeons, physicians from Scotland, many of them from Scotland, were deputed to East India Company, Calcutta, and that's how you find influx of the people who have brought a major difference to the science of paleontology in India now. Next, please. Well, when this was all happening, we find concomitant developments such as establishment of botanical garden in Calcutta, Saharanpur Botanical Garden, which is today known as Company Garden, Company Bagh, in 1832. And important welcome addition was Nathaniel Wallich, an eminent scientist, botanist, who also eventually became the superintendent. At that time, it was known as superintendent of Indian Museum, Calcutta. Next, please. Then, as a just quick look at, when we look at these definitions of colonial science, we realize one thing very clearly, that understanding the landscape, understanding its people, understanding the flora, fauna, natural history was a need of the hour. And keeping that in mind, we find that quick acquiring the knowledge of the modern flora, modern fauna, as it was essential. At the same time, in that process, we have this great personality, Hugh Falconer, who comes into India in 1829 as a physician, assistant physician to East India Company in Calcutta. is one of the best examples of exactly how colonial science is developed in the process of studies by these many people. I'll just take it to the next one, please. Again, we come across very interesting Basala's model that how basically the Western world bringing knowledge to the Eastern world is this area where it's not really so much known, rather, in fact, quote unquote, ignorant about all these developments which were happening in the West. So, flora, fauna, minerals, and so many natural issues of natural history needed this detailed documentation in this part of the world. So, how this all was being brought in, and that's how these people who came from the West, they started introducing, and the systematic study began as part of study of natural history in general, because natural history finds it's a term, and at the same time it's history going back to John Ray in 1627, and thereafter we see very successive development of natural history spanning into various parts of the universe in terms of the objects of natural history. Next, please. I do not see the slide.
Just wait for a minute, sir. The slides went off. I'm just
Oh, oh, oh.
reconnecting it. Just give me a second. So just give me some time. I am reconnecting. Till that, if you
Sure.
want, you can continue.
Okay, okay. All right. So it is in this process that we have a symbiotic relationship between science and imperialism. That's what the colonial science studies talk about. And so in this process, we find as I said before, the Dr. Falconer coming in, and thereafter this important personalities like Richard Lydecker, Guy Pilgrim, Edwin Colbert, all have made phenomenal contribution, and that contribution becomes a foundation of modern day paleontology, not just for collecting fossils, but coming out with detailed discussions on anatomy, detailed discussions on its evolutionary aspect of it, and that becomes undoubtedly the most important foundation of paleontological research in India today. Should I be continuing or should I wait for the slides?
Yes, I'm sharing it from my side.
Okay. Yes, 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 this one, where this personalities are, the photographs are kept. Yeah, yeah, yeah. Okay. All right. So you can just have a look at these photographs of these personalities, and should I continue? Richard Lydekker is known for his 19th century, late 19th century, that he was continuing his work across the country. He has also been, he has contributed extensively in paleontology indica. His work spreading from north to even Karnool caves in Andhra Pradesh is testimony to his important hypothetical models at the same time, information on the evolution and development and anatomical details of large animals. In, we have this Henry Osborne, Fairfield Osborne. He may not be having direct, so he may not have worked in India, but his contribution, especially with regard to dental anatomy, is very, very important. Besides elephants, voluminous work on elephants' evolution. And you have Edwin Colbert, his initial explorations way back, 90 years back in Shivaliks, and his records, which he has published from, from the Philosophical Transactions of Philadelphia. And Guy Pilgrim, in fact, we owe him for all his important monographs on various animals, his work. He was a garrison engineer. He worked in Narmada Valley. He worked in Shivaliks. He worked in southern India. And what we find is his contribution takes us to detail the evolutionary history of variety of animals, and his monographs, including the fossil bovidae of India, fossil giraffidae of India, fossil suidae of India, fossil cervidae of India. They are standing testimony to his contribution about these large mammalian paleontology, which enrich and which are the important, precious references for us in libraries across the country, across the globe, I would say. Next, please. Well, but science of gigantology or giantology was the most important aspect which was considered hitherto. But as we see, just if you want to see the look at the development of paleontology, we find three important stages through which the paleontology has gone and achieved all the important milestones today. One of the most important was the need to classify and place organisms into natural groups. So here comes this question of taxonomy or classifications. And Carolus Linnaeus, who was primarily a botanist, he came up with extensive work, and his important contribution is Systema Naturae, 20, 25, 23, 30 pages book, which tells us about the classification pattern, the classifying animals. In fact, today, if you have these animals such as cattle, buffalo, sheep, goat, elephant, and multiple, in fact, it's not just animals I'm talking about, the plant species as well, we will find them, they have been authored by Carolus Linnaeus. And that's why if we write a species name for elephant, I would say Indian elephant, Elephas maximus, and next to that, I'll put Linnaeus 1758. Indicating that Systema Naturae is the volume where he published for the first time, and he defined that this is Elephas maximus, which can be put into category of elephant, which can be put into category of maximus, and it is mentioned for the first time in Systema Naturae in 1758. So this is how he has extensively worked upon. And next, please. This classification has given us some fantastic data thereafter. As we say, global ratio of terrestrial, subsurface, and marine, and then we look at the Indian habitat, that we have 8% species of fauna out of global diversity, or just giving the example of 45,000 species of plants or 91,000 faunal species. So when we talk of species and talk of the identification, what is what and how different it could be from other species. Like for example, we have several species of birds, and in fact, let me confine to mammals then. So how do we classify them? The classification has given us such detailed count of animals. This is what this science of taxonomy or the study of classification has given to. So next, please, I'll take you to another one, which also tells us about, next, please, that 4.5 million living species of plants and animals today we have in the world, but only 250,000 species have been described. Fossil species have been described, less than 5%. So imagine this massive world of plants and animals, And if you don't classify what kind of a chaos it would be, and that chaos could be not just chaos of not identifying species, but can be a massive catastrophe for the mankind and the world around from all perspectives. So this classification has come into, in fact, today the science of classification taxonomy finds a very important position in zoology, that is neontology, and also in paleontology. Next, please. You can see in the top there are various fossilized remains of elephants, cattle, hippos, primitive elephants, primitive pigs, and horses, and some cattle, and rhinoceroses. But it's how to identify them. We need to have some kind of a comparative material to compare with and to identify with. So the bottom that I just gave some line drawings of various animal skeletons, and this is how the study began. So when we look at this need of frame for anatomical morphological comparisons of living and extinct forms, I find that when it was Georges Cuvier and of course Richard Owen, they came up with fantastic comparative material for analysis, and that's how, with the help of material, they were able to build up true castles of anatomy. But when we think of Indian contribution, we find Hugh Falconer having killed many animals in the wild in Shivaliks in North India, and he developed his collection of modern mammals. In fact, today, a collection of modern skeletons of modern animals is very important exercise that we all indulge in to develop our library of modern skeletons, and that can be utilized for comparative observations, comparative studies. As you can see that many bones could be incomplete, many bones could be incomplete from the perspective of that how to reconstruct exact species. We have reached up to genus, now how to go to species. In such cases, many a time this modern fauna comes to our help, and comparative observations are most essential part of paleontology today. Next, please. Next, the third was very important part, geological time dimension needed to understand the antiquity of Earth. So far, only this 4th October 4004 BC was the bottom line. It was a red mark, beyond which nothing can be seen, nothing can be accepted. But next, please. Over the period of time, with this more than 150, 200, more than 300, 250 years of extensive study in the science of geology, specifically determining age of Earth, we find a very systematic geological timetable, beginning with Precambrian, going up to Quaternary, divided into Paleozoic, Mesozoic, and Cenozoic. And that too, interestingly, we find paleontology having a pivotal role in this, because we see age of invertebrates, of fishes, amphibians, and mammals, all, and it's a golden era of mammals, that we find this all is coming up well defined by animal fossils. So their appearance, their disappearance also has a very important role in defining the age of Earth. So this timetable is a testimony to how important role the animals have been playing ever since the life came into being on Earth. Next, please. Well, when India was still having this not much of information available, so we have this American Museum of Natural History coming into being, Natural History Museum, London. Then we again find Darwinian gradualism rapidly growing and helping us in gaining ground in paleontology. And of course, there has been a lot of on account of world wars, but prior to that, prior to these all events, we have Colbert, Pilgrim, Simpson, Welles, Romer, Stephen Jay Gould, to name a few, who brought important data bank and vision and insights into the science of paleontology for world, of course, with special reference to faunal abundance of India. Next, please. I just quickly take you to the journey of this biosketch of this gentleman, the polymath known as Hugh Falconer, who lived barely for 57, 58 years, but he left behind a corpus of data that is coming as a foundation stone for paleontological research today. He was appointed as a chief assistant surgeon, and later on joining as a chief warden of botanical garden. And that's how, next please, his journey started. So in fact, rightly I would say, a rendezvous with the fossil record, that botanical garden, which was painted, like, and the painting of botanical garden the Saharanpur that you see on the left hand is a painting. On the right hand side is today Audyogik Prayogshala, and it's a horticulture and company bag, popularly known as today. And we find that the much of plants and horticulture and all that we find today flourishing has roots in introduction by Falconer. So we really owe a great debt to this man who made significant contribution not just to animals but also plants. Next, please. But when this was all happening, we can find Stephen Hislop, the person who came to Vidarbha, and he lived for barely 47, 48 years. He died on a horseback, going in a torrential rain. Sudden flash flood in a nala in Vidarbha. He had stone tools and notebooks and some bones in his pockets, and he was sitting on an elephant, a horseback. He was riding the horse to cross this flash flood of a nala, and there he was swept away and died. But whatever little time he had to himself, he has contributed very in big way, because what research he did carried out in Vidarbha led to discoveries of Cretaceous shells, the tortoise, the coprolites, and many other discoveries that we will see. Next, please. So what you see here is this Memoirs of Geological Survey of India, published in 1863. There you come across the variety of the shells, plastron, fish skulls, and variety of different dental and skeletal remains of dinosaurs as well as fishes that you find here, which were reported by not just Hislop but also Lydekker. But Hislop's contribution stands very tall as far as coprolite research is concerned. Next, please. So it was a village of Pisdara, very close to Anandvan, Baba Amte's Anandvan, which has become today a hot spot of dinosaur research. Today, the towering personalities such as Mohabe, Dr. Mohabe, and Dr. Wilson, and others, and they have extensively carried out research in Pisdara. Pisdara also has dinosaur in eggs, shells, molluscan shells, and also coprolites, and multiple evidence of Cretaceous period, Jurassic Cretaceous period. And here it is for the first time that he reported coprolites, and coprolites were studied later on. 60 years later, coprolites were taken thin section off and watched under microscope by Matley. Next, please. And next, please. Yeah, these are the coprolites found by Jeffrey by Hislop, and they all were most of them were examined, and thin sections were taken. And the Matley, the geologist for Geological Survey of India in 1937, he published an article in Memoirs of Geological Survey of India, Records of Geological Survey of India, and he says that all the coprolites or the fossil dung is of vegetarian, the herbivore dinosaurs, because we know that this is also a type of a fossil. And this fossil type is very, very crucial, because it tells us about diet, it tells us about environment, it tells us about the flora. If at all it has animal parts of bones and all, it can also tell us about the dietary habit of a dinosaur or an animal. Then what kind of animals lived around in the vicinity where these animals were moving around and trying to find their prey species. So the coprolites are very, very important part of paleontological research. Next, please. We further move to Maharashtra in Godavari. We find a very interesting reference of Guy Pilgrim. In 1905, in Records of Geological Survey of India, he reported for the first time fossil discoveries in Nandur Madhveshwar near Aurangabad and near Paitan and Rakshas Bhavan sites in western Maharashtra, going back to 1905, where for the first time he reported, next please, elephant skull, and also associated remains of cattle and hippos and other animals. And he also, because by that time he'd also studied the fossil collection kept in Geological Survey of India coming from Narmada Valley, and he was also familiar and aware of this geological succession in Narmada Valley. So he was the first, perhaps for the first time, he came up with this record that fauna can be compared with that of Narmada and Godavari, and biostratigraphically they should be of the same age. Next, please. Well, this is the map of India during middle of 19th century, where the red strip that takes around to Shivaliks in northwest India, and the little reddish strip near Jabalpur in central India were the only places where the fossils were known in the middle of 19th century. And so he's Hugh Falconer standing, and right below him, he's another friend and colleague, Prof. Cotley, who had started discovering fossils, but bringing a proper discipline, bringing them to discipline of paleontology was a very hard work of Hugh Falconer. Next, please. This is just a museum, Friends of Falconer, way back in 1875, after his demise of Falconer, in his hometown of Forres in Scotland. His friends and his family and his other community people of Forres, they came up with a contribution, and that contribution helped building up the museum, which is located in this very near to Council Hall of Forres. And this museum currently closed because the lack of funds in the Moray Council, but looking forward to opening soon with the more funds coming from various quarters. And this museum is one of the most interesting places where all the collection that Falconer had made, part of it is kept in it. Much of collection of Falconer has been kept in Natural History Repository of Indian Gallery and Natural History Museum, London, and also in New York, and also in other parts. Besides Geological Survey of India, Calcutta also has its major chunk of collection, which has been left behind. Next, please. Yes, these are his notes. He was very particular about jotting down his observations, and he made systematic documentation of all the discoveries. These are all fossils which he had discovered: a mandible of Symphysis, the front bone of hippopotamus, then and also rhinoceros, and then you have also ankle bones of cattle of Shivaliks. And this collection that you see here, the handwritten letter that you see here, you find very interesting details of his letters. His correspondence is very, very methodical, and he does not leave behind anything unturned. All his observations regarding field, regarding flora, regarding fauna, regarding the people. He has also left behind very interesting details of how he was, what he witnessed in the court of Rana Ranjit Singh in Lahore. So, and then that's how it becomes very important that all his library, all his literature, all his correspondence, all his field diaries had to be looked into to reconstruct his contributions in the form of a bio note. Next, please. Yes, quickly I run through. Next, please, because he has, for the first time in 1836, in Asiatic Researches, he referred to hexapododon shivalensis, that is hippopotamus, 6 incisor, and then there's no end to it now. In fact, that's just the beginning, and he embarks on a very voluminous work. He was very, very quick in publications, writing his detailed monographs and articles, and that's how whatever has been done by him is perhaps one of the finest exhibitions of methodical paleontological research of 19th century. Next, please. Just an example of how his faunal, the paleontological memoirs, Fauna Antiqua Shivalensis. Next, please. He used to make field diagrams in the field. So Wollaston Award, which was awarded to him, is one of the most important recognition that he received in Geographical Society of London. And this award was given to him jointly with Prof. Cotley for his joint contribution to Shivaliks. And he was also very particular about drawing the fossils, because drawing the fossils was only possible for him to understand the details and minute details of the anatomy. And his notes are a testimony to his scientific acumen that has given us important clues about this fauna of that time. Next, please. Well, 19th century followed by even we have this Geological Survey of India establishing in 1851, Indian Museum 1814, Asiatic Society 1784, and thereafter the list of luminaries that you see in the front, that Richard Leidig, Falconer, probably Courtland, many more. In fact, I have not given names of so many because it will be beyond the purview of scope of this talk today. If I had to talk about everybody's contribution, next please. But as we move into the 20th century, we have a very interesting example that how the scientific disciplines make it a reality that interdisciplinary research is needed for understanding these key concepts of paleontology. So next, please, I'll just quickly, because we are, I guess, falling short of time. Yes, another example of Hugh Falconer's contribution is he introduced Chaha, tea, to India. Not that he introduced, but he brought. He brought tea. In fact, that was a period in colonial, in Victorian times, when tea had to be brought in from China. It was very expensive for the East India Company. So East India Company wanted experimentation of tea plantation in this part of India, where the temperatures could be similar, landscape could be similar, and the environment could be similar, so that the tea plants could be successfully grown here. So the first experiment was done by Hugh Falconer, where he brought Camellia sinensis, the tea, and he started there. And so what tea we have today is basically contribution by Hugh Falconer. So Hugh Falconer's contribution to every one of us's cup of tea is great. So we always acknowledge with every sip of chai, we would say, yes, the tea has come from, introduced by him, not that he has planted, but he has introduced out of experimentation. And today we have tea from different parts of the country that are available to us. Next, please. Another important thing that he introduced was asafoetida, which is also colloquially, in colloquial English, they call it dragon's dung, Ferula asafoetida. This Ferula asafoetida today is, of course, next please. Yeah, today, in fact, we have been able to, we had a burden of $100 million USD, because this has to be, it's spent in getting this 1,200 tons of annual import of this asafoetida. But now, very recently in 2022-21, this in Himachal Pradesh in Spiti Lahore, this asafoetida cultivation is experimented, and now we are finding it important yields coming in. So hopefully we will be able to combat, or we will be able to counter the expenditure which comes on account of import of asafoetida from outside India. So this is a very important achievement which has become possible with modern day experimentation in Himachal Pradesh. But initially, the credit goes to Falconer for introducing asafoetida to India. Next, please. Next, please, again. When we enter into post-independence, we have stalwarts like Professor Amar Sahani, Birbal Sahani. We just had a fantastic lecture by Professor Ashok Sahani. Then we also have M.A. Shastri, Tripathi, Das Sarma, Basu, and their pupil, of course, Nanda, Badam, S.R.K. Chopra, and his pupil. So this towering personalities and their pupil have made very important contribution to the field of paleontology today. But when just see them, a few examples, we can see in the subsequent slides. Next, please. From the following two, in the sense that Ava, Irrawaddy Basin, Shivalik, Piram Island, Narmada, all just these four have been the initial locations of discovery of fossils and building up the entire paleontological theory as far as the mammalian evolution is concerned. But as we go further, this is all happening till 19th century, or beginning of middle of end of 19th century. But next, please. As we go further into time, we have, next please, we have this various establishments already taken place, such as Geological Survey of India, Calcutta. You have Punjab University, Chandigarh, Wadi Institute of Himalayan Geology, Deccan College, Pune. These are all places which which have developed now today as the and resource where the resource persons can contribute to the science of paleontology. And the paleontological literature that we have today in India has very important contributions coming from these scholars from these institutions. Next, please. Yes, this is just to show you the map of India, where the initial, all the the green pins showing this 19th century research in Kashmir and also in Shivalik, so northwest India, where it was all British India part of that. So we have Ramnagar and also in Parmandal, entire Himachal Pradesh and Jammu, that we have these a few locations were discovered at that point of time, followed by next, please. We find again now we start finding the green pins which are indicating this post 1947 and pre 1970 discoveries of fossils. And next, please. In Shivalik, so northwest India, and also in Karewaz of Kashmir. But here, when we come to the central India, Spilsbury and the person who deciphered the Brahmi script, James Prinsip's report of in Asiatic Society of Bengal volume published in 1833, the discovery of fossils from Bhedaghat near Jabalpur in Narmada Valley heralds one of the finest contributions in paleontological research in India, because it's close to 200 years now. And yet, we have very important set of fossil data emerging in every excavations and every fieldwork, post monsoons or even an excavations as well. So this, and when we further come into Hingoli and Madhameshwar and Nandur, Madhameshwar and Munki, Thomas Wynne in 1863, he was the first to discover Acheulean at the Middle Paleolithic flakes, perhaps 5 to 6 years before Robert Bruce Foote discovered tools in Pallavaram, Handex in Pallavaram, in Tamil Nadu. So this is how we find the contribution of this colonial natural historians and geologists and garrison engineers has been really important one. Next, please. Further move into this more sites. In fact, I have not given too many sites here because of that map. You can't just figure out what location is mentioned where. But if you see here, the green pins, the green pins are now today are telling us about, as I said, Colonial caves is of the 1849. It was discovered for the first time. But please take me to the next slide, please. And you can see here yellow pins coming up, filling up more of area, more of discoveries. So finally, in Tungabhadra, in Hunsgi Baichibal in Kalaburgi and surrounding areas, Kanul caves in Andhra Pradesh, and Bhima, Ghod, Manjira, in the Harwadi and Bangdari area of Manjira. Then you have this Rangnag Jhola in Wardha. You go further up in Nandgaon in upper streams of Mahanadi, and also in Narmada Valley, and further up in Belin Valley, you have this cluster of sites running into hundreds. And these sites, many of them have also yielded Acheulean artifacts or Mid-Paleolithic artifacts, indicating that yes, this area certainly was shared by, the landscape was shared by the prehistoric man. And no matter whether we find bones having such cut marks upon them, it's very obvious that these animals were providing enough food source for these prehistoric people. Next, please. Next, please, again. And further down in Tamil Nadu, we have some more sites such as Sayamalai, Ayanadipu, and others. And these sites have been reported in 70s of 20th century, 70s and 60s and 70s of 20th century. And that's how we find slowly the entire map of India getting started with these fossil sites, mention of fossil sites. And interestingly, I not brought the map of Sri Lanka and talking about Sri Lanka here. But let me say that yes, there has been land bridges in between, which enabled movement of animals. And that's how we have hippopotamus and elephants and cattle and buffalo and other smaller animals such as deer and antelope and all, having traveled from this mainland and finding these corridors for migration. And you find them in the deposits of Ratnapura formations in Tamil Nadu, in Sri Lanka, which have been extensively studied by Professor P.P.P. Derani Agala way back in 50s and late 60s of last century. So that's how you can see the entire map of India, including subcontinent. If I say, if I'm including Sri Lanka, we can see the spread of fossil sites and giving us important clues about prehistoric migration and distribution of animals, and letting the congenial environment allowing them to survival for such a long period of time. Next, please. So when we come to this modern Renaissance, we have a lot of other things. In fact, I'm just putting these details in terms of small bullets, but these bullets would really take a long time. But I'll just quickly run through that. Identifying animals, as you have seen the stages 1 and 2 and 3 of paleontological research, which all happened in 19th century. We see here is that identification, anatomical, taxonomical positions, then state of preservation. This modern Renaissance takes multiple applications into consideration to arrive at precise identification, precise anatomical position, and also in terms of its preservation and finding out whether these fossils, which I'm finding at this particular point at a point of B, are was the B area, the point B was the area of survival of these animals, death of these animals, and burial of these animals, and discovered by subsequent paleontologists at the same site of B. If that's the condition, then we can certainly say that yes, we are dealing with the primary context or the autochthonous assemblage, and then the reconstruction of environment or reconstruction of entire natural history of that area would come to will conform to the reality of the past. So when we say present is the key to the past, employing this borrowing information, drawing information from the modern day fauna, flora, can help us in reconstruction of this past environment successfully. So that's why paleoecological analysis draws heavily on the science of taphonomy, science of preservation of fossils, discovery of fossil record, and how we can reach close to the coordinates of its actual ancient survival, death, and burial, and fossilization and discovery. Well, another important development in the science of paleontology of modern day times is microscopy of calcified tissues. So teeth and bones are the most important sources of data. They can be examined at a microscope. They are being examined at a microscope. In fact, Professor Sahani's pioneering research in microscopy of teeth has given a solid foundation for dental histology in India. So, and we have also currently in our laboratories, we have several students studying this bone histology of various animals and trying to figure, like cattle, buffalo, sheep, goat, or even for that matter, Pleistocene and Holocene, the horses. And that's how we reached to the conclusion that whether environmental change or dietary change has been responsible for any kind of pathological lesions or arrested growth lines, or the microscopic features of bones and teeth, they conform to health or other aspects of this fauna of the Pleistocene and also modern. And the same thing that takes us to this platform of paleopathology, paleodiet, and subsequently, without studying the paleonomorphs or the pollen grains and paleovegetation, reconstruction of is often difficult. So we talk about this fauna in the context of flora, and for flora, the fossil site, which we have excavated, taking the soil samples for paleonomorphs to reconstruct the paleoflora, becomes the most important, complementary, not just complementary, supportive, not just supportive, I would say, rather a most important part of, inevitable part of paleoecological interpretations of the fossil site. Well, as far as DNA is concerned, it's very difficult because the organic molecules, they die pretty fast in the conditions of that India has, subtropical conditions. The survival is a big issue. So we've not been able to successfully extract DNA from those Pleistocene fossil record. But of course, Holocene, it has become possible, but Pleistocene, it becomes difficult now. So we still put it with a question mark that really can DNA be extracted or not. Next, please. Thank you very much. This is Mary Anning, and this is Ichthyosaur, and she's feeding him. And this is a very interesting reference to Mary Anning and in fact, I dedicate my talk of today to Mary Anning for her astounding work in the field of paleontology of 19th century. Thank you very much.
Thank you, sir. Thank you so much. It was really a wonderful lecture, and you enlightened us with many new things which we were not aware about. Thank you so much, sir. With your permission, can I take some questions of the participants?
Sure, sure, of course. Yes, yes.
Thank you, sir. Thank you so much. So, that's a question by Manali. I'll read it out for you. In your own explorations from Narmada to Manjara valleys, what moments stand out as examples of fossils capturing the imagination of local communities?
A very
That's the
good
question.
question. I didn't touch upon this issue at all because it would have been again going beyond limits of time today. As it is, I started late. Well, uh, s- explorations in all these sites. Let us go back to the period of. I'll start with my experience that when I was exploring in Majra Valley, also in Namada Valley, first and foremost, the curiosity grows beyond levels of imagination. That why should a person from city coming and exploring in the jungles, and what is he looking for? So when I was exploring, I was repeatedly asked by the older women who were fetching water from river in the pots that what are you looking for? What are you doing here? And then I said I'm looking for fossils. So they immediately said, "Oh, you're looking for the fossils of demons, the Rakshasachi Hada, or you can say that Rakshasoki Haddiya." So everywhere, and this statement, what she asked, the question that she asked me, that question is referred to in Tariki Farishte of Muhammad Farishte's compendium on Islamic history. 1360, year 1360, when this Muhammad Farishte published his account of northern Indian, his Islamic rule and what things were happening around. Basically, a kind of a court historian. He was keeping all the documents. So he writes about India's history of 13th, 14th century. And he says that when there was a dam irrigation, dam and canal digging was going around, and near in he referred to, I guess, sites near Peshawar and also in this part of near Himachal Pradesh. So he says that uh, people refer to these as the bones of augurs, which we can say the the bones of titans. So the bones of titans is a common thing. If you push it back into times of Herodotus, you find Herodotus referring to a city of Megalopolis. And he says that in Megalopolis, there has been extensive so war between Zeus and Titans and Zeus. And in that, Zeus were killed. There was a massive lightning on account of Zeus's power. The Titan, all the Titans died. They got buried, and because we find their bones in megalopolis excavations or at the river sites, we find their bones and they're all black because lightning. But later on, when the research was carried out in this area, it was found that these are all basically the tar pits, tar pits, hydrocarbon seepages. And these tar pits leave behind the color of the bones black, but this prehistoric people, and but this historians of the third, fourth, fifth, sixth, or seventh century did not know exactly what are they looking at. Are they looking at real fossils or the imaginary fossils, imaginary objects? So they describe them like that. If you go back still in further in time, go back to the Scythian
Thank you, sir.
times in
Thank you
central
for
India.
that question. We have another question by
Sure.
Nandan Shastri ji. The question is, stone tools of Homo erectus are found in Hunsagi, Baichabli Valley in Karnataka, 1 to 5 million years old. What is its major highlight? That's his question.
Its major highlight is about the first of all survival of these prehistoric people in that area. Hunski Baichwell area has 6 to 7 sites, and this 6 to 7 sites, Kaldevanhalli, then I don't remember the names now, but these all sites have yielded Acheulean artifacts which are very well dated. In fact, the date that has come for these tools is based on the dating of some of the material fossils there. The date goes to 1.2 million years, so almost like close to 12 lakhs that time can go to. And the tools are really large in size, hand axes, cleavers. As we proceed further in time, this entire cluster of 6 sites of course, there are multiple sites along this Baichable Valley which have been explored, but some 6 to 7 sites have been systematically explored and excavated by Professor Padaya, my professor in Deccan College, and he excavated for nearly 40 years. And from his excavations, we have a continuous record of human presence from Acheulean up till going. In fact, there are certain locations where we have Mesolithic artifacts going to hardly a few hundred years, a few thousand years. So this, when you talk about the highlights of this site, I would say the important part is that this entire area in ancient times, this has been away from the mainstream. We do not have the fossil record which is found is not derived from, or the stone artifacts, they are not derived from the actual, what you call it, riverborne deposits. And the activity, the most important highlight of this part is that whatever we are finding at these sites today are not at all moved away from by any other natural factor, natural force. And autochthonous discovery tells us about successful cognitive evolution of this prehistoric man in Husky-Bajpur Valley. Otherwise, it would have been, perhaps we would have been saying otherwise that yes, they could have been deposited there, they could have been employed. But looking at the typology of this fossil, the stone artifacts, some size and dimensions wise, they come as one of the most extraordinary patterns of hand axes and others, which we do not find in other parts of the country. So this extraordinary size, its occurrence, its association with prehistoric animals are the most important highlights. Another thing is that for the vertebrate fossils which have been found along with in association with these tools are more, in all probability, they're contemporary to one another. But A. B, that these fossils do not come across, they're not found in the vicinity of fluvial channels. So there is least possibility of having been transported by the water activity. So what stands here is that we are sitting at a very important primary site. Disturbances have been dismal, minimal, and a fossil record that is also, most importantly, yielding a tiger bone, which has been very important, which has been very rare otherwise. We have a huge collection of large mammals such as elephants, cattle, buffalo, from the Acheulean levels. But also for the first time, there is one of the small piece of ankle bones we have here, that is calcaneum fragment, which is identified as that of Panthera tigris. And if I'm allowed to say, this comes as a huge discovery because a tiger's presence in India as a huge question mark. Can we really stretch the history of tiger in India that ancient as a question of it stands. So I can say that it stands open to revision because not many other tests, examinations are being conducted before we come to the final conclusion that this was really tiger or some other large predator. But the fact remains that when the fossils and tools are in same context, there are a couple of artifacts which have yielded, there are a couple of fossils which have yielded cut marks on the bones, which are confirmed cut marks by human activity. Once again confirms that this site, Husky-Bajpur Valley, the complex of these sites, is emerging as one of the most important autochthonous sites of human and animal activity in southern Deccan of this part of the country.
Thank you, sir. Thank you so much. So there are multiple other questions of Manali, which I would like to put in front of you. So her next question is, your slides show extinction windows for late quaternary megafauna. How far do you think human interaction, hunting, habitat change was responsible compared to climate or ecological shifts? That's our next question.
That's a good question again, because there are two things involved in this. When we talk of overkill or man responsible for the extermination of most of the large mammals which have become extinct at that point of time. They became extinct because of killing by prehistoric man. Logically, yes, they have been responsible for, but wiping away the population of animals, that particular genus and species, only by man looks like not very feasible idea about, because we don't, first of all, we don't have any site except Hunski Bajpal Valley, no, and also one or two examples from Manjra Valley, that we have any example. We have thousands of fossils from Narmada Valley. I have gone through literally thousands of fossil collections from Narmada Valley, from Manjra, from Godavari, from Ghor, from Kanul Caves. Kanul Caves, of course, is a different aspect altogether. But here, this from Pleistocene fossil record, except Hunski Bajpal Valley and Manjra Valley, we have no such record to show that there is human activity on bones. So there's a possibility, but there are two aspects in this. One is that yes, man has been responsible for not extermination or wiping away the species, but making use of these animals as a source of its diet. But another reason could be climatic change, and interestingly, as far as India is concerned, unlike other parts of the world where climatic change has been drastic, India did not experience such an important climatic change, such decisive climatic change. So in Pleistocene to Holocene, the last glacial maximum, which is supposed to be known as very dry and cold and leaving behind this depletion of natural resources, and at the same time not really finding congenial environment for the animals to survive, that drastically doesn't happen in India. And that's why, if you see, I have shown my second slide was all talking about the dates and the number of species. You see hardly, except hippopotamus and two primitive elephant species and one ostrich, you don't have any other animals disappearing from that period of time. So continuation, in fact, one very good example that emerges from Kanul caves, where there is a continuous fossil record for over 100, something like 120,000 100 years. In that, you find that the fossil record is continuous, the species found are continuous. There's hardly 4 or 5 that you find disappearing, and the similar thing happens in this part of the country as well, where we have across India, unlike what happened in Pleistocene, beginning of Pleistocene, did not happen in end of Pleistocene. So last glacial maximum may have been a very drastic step for the rest of the world. India did not have such a drastic phenomena happening, which could have been responsible for extermination of entirely all species. We know for sure that the hippopotamus has become extinct from India towards the end of Pleistocene. But it was because of man, or entirely, or because of climate? Because hippopotamuses are absolutely, their aquatic environment is important. They cannot survive without water. If there is a drought, they can survive with mud. All they need is to cover their body with mud, because of that will arrest evaporation, excessive evaporation from their body of water, and they would not die of dehydration. But if this continuous phenomena of drought continues for years together, even the river basins having their places of deeper water bodies, stagnant water bodies, are also depleted, completely dried out, then I think there's no future for hippos except that they die out and disappear. And if this is happening practically all parts of the country, as we see that the fossil record of hippos disappears after Pleistocene, it's a very important, because hippopotamuses, modern species, have been studied extensively, and their dependence on water has been documented extensively. And it's very obvious that hippopotamus cannot live without water. So here, as far as hippos are concerned, rather than calling it as a overkill phenomena by humans, we also have to accept the fact that climatic change, which was also leading to drying up of basins and water bodies, definitely was the cause because of which the hippopotamuses became extinct. And as far as other mammals are concerned, the vegetation, depletion, and loss of habitats and shrinking of habitats was another important reason that we have been able to document in many of these areas in peninsular India.
Thank you, sir. Thank you so much. We have three more questions. If you permit, could we take them?
Sure, yes, yes.
Okay. So Supriya Bansode has a question. Given the poor DNA preservation in Indian fossils, how reliable are paleontology and microfossil studies for reconstructing past ecology and evolution? That's her question.
Are they two different things? They're two different things. When I'm saying about how reliable paleontology is an established and branch of research in paleobotany, which studies the pollen grains. Now, it's a well-documented research that documents the preservation of pollen grains, and then taking with the sediment samples, examining them under a microscope, following the protocol of paleontology, it has become possible. In fact, you will be surprised to know that the Metley's coprolite analysis, which was done on Pisdura dinosaurin fossil excreta, which was also examined by Professor Sahani and his team, including Prosenjit Ghosh from Bangalore, and they came up with the kind of flora that must have been consumed by the dinosaurs. So when we talk of the study of these pollens and study of this paleoflora, pollen's preservation is very much a reality. And pollen's preservation, pollen's identification is also very much a reality. Of course, you have to have a modern flora as well. As I said that for animals, we need to have modern mammals for comparison. We also have to have modern, that's why the herbarium is most important collection part of activity of a botanist who is collecting data from modern flora. And at the same time, having a library of modern plants as far as pollens are concerned is an essential exercise. And from that, we can compare if at all there has been destruction on account of taphonomy, that the pollens have not been able to survive or have been damaged, we can clearly see the comparison and figure out exact identification on the basis of those microscopic structures of the pollens. And that got nothing to do with the DNA. With DNA is something which is going into the ultra ultra level of preservation, and it's very sensitive. It just if it's because basically collagen disappears. What happens in process of fossilization? First of all the organic molecules disappear. The depletion happens first. Dehydration of bones dry out. They're inside whatever collagen and water content they have, which is supposed to have the DNA preserved, itself disappears. It goes away, it destroys. And after that, the bones are left behind empty. Empty in the sense all the molecular spaces of the bones are left empty. And then the influx of sediments get in. And then actually the process of fossilization begins. And with that process of fossilization, when the mineralization is complete per se, then we can say the bone is mineralized, or we can say the bone is fossilized. Even if gelatin and lipids all are given away, we do call them sometimes the this petrification has taken place. So in such a case, when we have no such possibility of preservation of organic molecules, because the entire the body of organic substance which preserves organic molecules is also gone, then finding a way the DNA is very difficult. Sometimes you may find just a strand, and multiplying it to the level of understanding its entire history is next to impossible. So this always, but that happens only in the conditions like what we have in India, in permafrost conditions, or even the colder conditions such as what we have in America or Europe or certainly Asia. Certainly, we have the documentation possible, and it is for this reason that when we have a baby elephant discovered in the form of a carcass from Siberia, they have been successfully able to reconstruct the DNA history of the animal. And now, in fact, we all know for sure that very soon we are going to have a mammoth reincarnated by the genetists who are trying to do the cloning. But that aspect is beyond imagination, or perhaps back up beyond of any imagination as far as fossil record in India is concerned.
Thank you, sir. So we have another question by Manali, and the question is: after independence, You note hiatus, but also emergence of institutes like Deccan College, Wadia Institute. What to you is India's most distinctive contribution to global paleontology since then?
If I had to describe each one of them, the
No,
then
I just
multiple places that we have. Uh, After independence, you note a hiatus, but the emergence, also emergence of institutions like Deccan College, Wadia Institute, Punjab University. Yes, uh, distinctive contribution. Okay. First of all, reconstruction of paleo environment, which is the first objective of paleontology. If you study paleontology as a student of paleontology, when you start reading the literature, you realize that three primary objectives: reconstruction of environment of the past, biochronology, how we can make use of these fossils, and figuring out how they can be a mode of, they can be source of data for dating. At the same time, their occurrence in various geological levels can also help us in biostratigraphy and deciding the age of Earth. And thirdly, when it comes to Pleistocene archaeology, I would say thirdly, man and animal interaction, where man is, of course, drawing its survival source from these animals by hunting them. So I would say in all three spheres, all these departments, all these institutions which I referred to have made very, very important contribution. Because when we talk of paleoecology, what we require for paleoecology, the requirements of the field and the laboratory techniques that have been developed over the period of time in the last 40, 50 years are phenomenal. And the major driving force, inspiring force, or I would say inspiring personalities like Ashok Sahani and many more in the field are really the guiding figures, guiding torches for us that we as a student of paleontology began exercising these aspects of paleontology, exercising this, the study of fossils, primarily to reconstruct paleo environment. So today, it has become possible to go down to the level of the fossil areas to reconstruct environment in limited areas, and then comparing it with other sites and figuring out at one point of time how could have been the environment in different parts of the country. One thing. And second thing also, these important developments such as for ecological reconstruction, we do a lot of isotopic research, and that isotope research is the most modern currency of paleontological research today. So every institution you'll find, every publication that you come across in paleontology, we see that the isotope research for figuring out what kind of diet these animals must have had, what kind of rainfall it was witnessed by these animals and also people, and at the same time, what could have been the source of water, and that source of water also can help us and reconstruct the ecology of the area. So, paleo temperatures, the rainfall, the diet, three important objectives are finding very crucial technology available at hand today in various institutions. May not be available in every institution that we are discussing about, but today the collaborative research has taken a front seat today. So you find collaboration happening in practically all institutes, and with collaboration with Indian institutions as well as institutions from abroad, it has become possible for us to highlight these areas, such as just you were asking about what are the points. Lastly, I would say that as far as the diet and paleo diet is concerned, with regard to a microscopic study, today in India, microscopic studies of bones and teeth are making phenomenal contribution. And this all began with introducing paleohistology to India by Professor Sahani in late 70s. And what we have today is we have been able to follow the guidance of those towering personalities, and then thereafter there has been extensive study done on elephants, cattle, buffalo, small vertebrates, microvertebrates, and they are taking us to the very, very precise information about the diet, whether this modern day fauna is having a relationship with the past, if there has been, because of biomechanics, how dental evolution, dental architecture, how that is changing and also leaving behind its impacts in histology. Same thing happening with bones as well. So paleopathology, paleo diet, phylogeny, all finding justice in modern day paleontology of India today, I would say.
Thank you, sir. There is an announcement for the audience. The next question will be the last question, and if any other questions occur, please put them in the chat box. We will let the resource person know about it through email or WhatsApp, and we will get back with the answers. But in live session, this will be the last question. So Supriya Bansode has asked another question, which will be the last question of the session. Given toponomic bias in India, how reliable are micro remains for reconstructing past diets and ecology? That's
A
the
good question
question.
again. All the questions are very, very pertinent. This question tells us about that if taphonomy is deciding the future of bones and fossils and their preservation, then how micro can be taken care of as a reliable source, considered as a reliable source. I would say yes, why not? Micro, when we look at micro, I'll start with um, microvertebrates. If you think of microvertebrates, such as different species of rats and mice, they have a short home range. We know they can't go beyond 1.5 kilometers or 2 miles. Their habitat is surrounding that. And we know with the help of modern fauna, modern counterparts of those microvertebrates, we know exactly what is the ecological requirement, where they live, what kind of home range they have. So wherever they have been found, first of all, we have to see how preservation is. So as just now I was referring to, for example, I'll just hop to another aspect of taphonomy, aspect of paleontology. That is, when you're talking about microfossils, I'm specifically confining myself to pollen grains. If you don't have preservation, fine, you don't find them at all. But if you have preservation affected by taphonomic processes, then we have to see them under microscope. But when it comes to the large bones, studying the large bones, we can examine and we can figure out the transportation and deposition, how authentic this must have been with course of time. But especially when we are talking about the micro remains, when short home ranges help us in reconstructing paleo environment of this small vertebrates. Similarly, the smaller microscopic organisms do have their own shape and size. If that's not preserved under microscope, they're absent. But if they are preserved, definitely they speak of their least exposure to any such devastating forces of nature.
Thank you, sir. So we have come to the end of the session. We want to know that your message towards the history enthusiasts. So, if you had to identify one unanswered question in Indian paleontology that the next generation should pursue, what would it be? So that will be the final question from the history
I don't
enthusiast.
think I don't think any we can pinpoint on any one. They're so interconnected. So if I say that okay, you have to find out the ecology, ecology alone can't really stand with a standalone flag that okay, it can be, because it has multiple dimensions of investigations. But for that matter, when we say extinction, because the extinction of dinosaurs, we all know for sure. We had a very good talk yesterday, and we got to know so much about dinosaurs extinction. Now, then extinction of many ancient vegetations, extinction of the Pleistocene mammals, especially in Endopleistocene, I was referring to. Another interesting part would be that what causes extinction, and can we really come to that conclusion? Extinction of mammalian fauna in the Pleistocene or Endopleistocene, and evolutionary links and origins of different mammal species. For that, DNA research is very, very important. But at the same time, I would say that if I speak only about laboratory challenges, then paleontology cannot be studied in laboratory. Paleontology begins with the field investigations, field documentation, field studies, and then the material that has been brought in takes a second stage of analysis, and that takes you to another stage of microscopy. It's a long journey from field to microscopy, or not microscopy in particular, but to laboratories for fine resolution studies. It's a long journey, and that's why nothing can be kept in isolation. The field has to be very properly documented. The field observations have to be up to the mark. So what is happening today with open eyes and ear, I think that is needed for continuation in future generations as well.
Thank you so much, sir. So
Sir is
now I
asking
request,
something.
yes,
Yes.
now I request Nandan sir to unmute himself.
Am I audible?
Yes, sir.
Yes, sir, you are. So you again went on mute.
I would like to suggest to explore the possibility in your organization to hold a seminar on uh, paleontology perspective uh, globally, uh, especially with respect to the status in India yesterday, today, and tomorrow. What do you envisage about research in paleontology in future also? You may reframe the title, but that will be helpful to many research scholars. That
That's a
is my
very, thank you so
yeah.
much. It's a very interesting suggestion and very important so guideline for any such interaction. In fact, uh, organizing a seminar with modern advances and the introspection, retrospect,
Yeah.
introspect, all is very important, and we need to have a funding possible. And if, in fact, in the days of uh, online programs, it can be held online as well. And if at all, if it's possible, it's not possible to raise funds, then maybe it can be held online and have series of talks and interaction enhanced to address the questions of paleontology.
Okay. Thank you.
So very good suggestion. In fact, I'll take it now and I will discuss with my colleagues in office, because since uh, they will be able to pursue it and
Thanks.
in practical terms.
Yeah.
Thank you so much, sir. We have come to the end of the session. Now I request Honorary President of the History Enthusiast, Nandan Shastri ji, to propose the vote of thanks.
I am overwhelmed by today's lecture, in which you have taken us to the journey of paleontology with respect to India, and uh, the question and answer session also very interesting, and uh, the attendees also uh, have attended your lecture in large number, and the history enthusiast group will uh, look forward for uh, in our future program your lecture also. Thanks.
Thank you so much. And in fact, I'm sorry the entire thing got delayed because of my the connectivity problem. So I hope thanks
Not
for
a problem,
bearing
sir.
with the
Not at
time
all
delay.
an issue. It was really an eye-opening session. Thank you so much, sir, for joining the platform of the history enthusiasts. And in future also, we expect your support and
I'm always
collaboration with
there.
these.
I'm always
Yes.
there. Yes. Yeah.
Thank you, sir. Thank you so much.
Thank you so much.
Uh,
Thank you.
we are signing off here. Before that, I would like to
Sure.
make an announcement. The valedictory session will be held at 4 p.m. today. I request all the audience to join the valedictory session at 4 p.m. sharp. Thank you so much. We'll be
Thank you.
logging off here. Thank you.
Yeah, sure.